Hi everyone, welcome back to Mind Over Math. This is part 2 of rational functions, or hyperbolas, and their asymptotes, horizontal, vertical, and slant. This is the second part of the rational function graphs and asymptotes, particularly the horizontal asymptote. You'll notice that I have some examples here at the bottom of the page where the lead term is where the horizontal asymptote comes from. The lead term has different beginnings. In the first one here, you will notice that the lead term is negative 1 over x. Well, that reminds us of the 1 over x hyperbola, and in this case, the axis of symmetry will be y equals 0. Anytime, that's what these instructions mean right here. Anytime that the exponent in the denominator is larger than the exponent in the numerator, say it the other way, the numerator is smaller than the denominator exponent, then the horizontal asymptote will be y equals 0. The second case here is with lead terms that cancel each other out. Y equals 2, it would be the result of 2x over x. Y equals 2. And that would be the horizontal asymptote. So in that case, it would be a over b. Here's the b, here's the a. The third case is different in that the numerator has a higher exponent. That's when m is greater than n. The numerator has a higher exponent than the denominator. In that case, we're going to have a slant asymptote. The slant asymptote will be in the form of y equals mx plus b. So we'll illustrate each of those concepts. The first one is negative 1 over x plus 1. And to find the vertical asymptotes, the first thing you do is you set the denominator equal to 0. So that means x equals negative 1. So that would be the vertical asymptote here on the graph. Vertical asymptote. X equals negative 1. Next, we would come to the horizontal asymptote, and that comes from the lead term set equal to y. In this case, and this is the point, y equals negative 1 over x. Those are my lead terms on this one. So this one has the same horizontal asymptote as does the 1 over x, and that is y equals 0. So that asymptote will go right down the x-axis. So that is the horizontal asymptote. And then the x-intercept and the y-intercept, in this case, the x-intercept, you set the numerator equal to 0, and that is a nonsense statement. That means there is no x-intercept. And then y-intercept is the constants. In this case, negative 1 over 1 is negative 1. So we'll put that on the graph right here. So this gives me an idea, at least, that since the vertical asymptote is right here at negative 1 and it's at 0, that means the graph must be at least in the third quadrant there, something like that. Then I would have to test a term on the left side, let's say negative 2. I'd have to plug it in to the function and see what number it would give me out, whether it's positive or negative We'll find out. Looks like it is 1 over 2. It is positive. So that tells me that this would be positive 1/2 right here. So let's erase the intercept. There we go. And now that tells me that the upper part of the left side of the hyperbola will be like that. Second one is 2x minus 1 over x plus 1. And again, the denominator is determined by set equal to 0, determines the vertical asymptote as -1. Same as the last one, so let's put that on there. -1. And then the horizontal asymptote is the lead terms this time. Y equals 2x over x. Those are clearly the lead terms. And that reduces to a simple 2. So y equals 2 is the horizontal asymptote. Then we come to the x-intercepts. That is from the numerator, so 2x minus 1 equals 0. So x equals 1/2. That's an x-intercept, so that would go right here. And the y-intercept is the constants, or the last terms would be -1 over +1, which would be -1. So the y-intercept is -1. Well, at least we can see fairly clearly that the graph is going up right here, comes around, stays below, y equals 2. Next question is, where is it on the left side of the asymptote? Is it to the left of it? Where is it? Is it above or below the horizontal? Let's plug in a number. Let's take -2. So f of -2 equals 2 times -2 2 times -2 minus 1 over -2 plus 1. So this gives me -4, which is -5, over -1, which is 5. So that tells me this is up here, right there at -2, 5. And so that tells me the left side of the hyperbola comes down like this. Okay, and then the last one is what happens when the exponent of the lead term is larger than the exponent of the denominator. That's what all this is saying. When m is greater than n, the top is greater than the bottom. Then we take the vertical asymptote, which is again x equals -1. That one's always the same. And let's put it on our 1. And then our horizontal asymptote turns out to not be a horizontal asymptote. It is x squared over x. Those are the lead terms. Reduces to just an x. This means y equals x is the slant asymptote. It has a slant to it. We're going to graph this asymptote. It has these y equals mx plus b pattern. It starts at the origin, 0, goes up 1 and over 1, and would be a dotted line that goes up something like this. And that is my slant asymptote. The truth is the horizontal asymptote wasn't there. And then the x-intercept is the numerator, x squared minus x minus 1 is factorable into x minus 2, x plus 1. Setting each of those equal to 0, we get x equals 2 and x equals -1. Now these are going to be very helpful because if you look on my graph, x equals 2 and x equals -1, oops, let me stop at this point and make a change. You'll notice I made this an x minus 1. It was an x plus 1. I have a reason for that. Let's set that equal to 0. And our vertical asymptote will be at 1 instead of -1 as it was before. So let's put that in. All right, now we're ready for the last step. We've got our x-intercepts that were 2 and -1. And so the y-intercept is the constant, so that one is y equals -2 over -1, which is 2. So let's put this on here. And now I think we can see a pretty clean pattern here. This graph goes up this way, up to there, stays to the left of x equals 1. Okay, so that's that part. And on the right side, we have this point right here also, which is to the right. It is to the right of the vertical asymptote. So we're going to draw that in something like this. And so this is a discussion, again, on how differently a problem can turn out that has different lead exponents. Since the lead exponents are mainly about the horizontal asymptote, that is sort of the issue here. Horizontal asymptote, should it be y equals 0? Should it be the two numbers in front? Or should it be these numbers? Or should it be a slant asymptote, as in the case when the numerator has a bigger exponent than the denominator? Hope this helps you out a little bit in the process of understanding rational functions. Thank you.
A little reminder that there is a part 1 and a part 3 to follow. In the upper right hand corner, make sure you subscribe. In the upper left hand corner, make sure you check out other videos. Likes are below and make comments on topics you need.